Okay, so we're going to do a couple of things. We're going to do some more algebra substitution. There's a little bit of BEDMAS here. It really reviews a lot of the stuff we've done so far, all those little skills, and then a little bit of graphing. But then there's sort of two things you need to learn how to do today. The one thing we're going to look at is called the left side, right side check, so we're going to do that in a minute. The other thing is an understanding of how the left side, right side check matches the graphing that we're going to do. That'll make more sense once we've seen an example, but those are the two big things we have to get out of today. Okay, and I'll point them out again once we've done this example. But while you're working, you want to be thinking about those things. There's this, we do a lot of graphing lines in grade 9, and then we see it again in grade 10, and it's like, people get good at it, but often are missing this really important connection of what it is we're doing and like what a line is, okay, and what the points are that are on that line. So forget about this example for a second. I just want to show you something. If an apple costs $2, one apple costs, that's an expensive apple, but one apple costs $2, I can represent that relationship. The relationship is how many apples you buy dictates how much money you're going to spend. You all understand that. Like every single person in here understands that very well. $2 per apple, you buy 10 apples, that's $20. It's easy. But mathematically, we want a way to represent that. There it is. The number of apples is X. I put 10 in for X. Y is how much you spend. 2 times 10 is 20. $20. Right? Again, that's easy. And this is an easy example that you can see how a linear relationship represents something in the real world. But this one's easy, so there are more complex relationships, and the math gets harder. But always remember that that's what we're doing, is that idea. And so then if I do this, so 10 apples cost $20. If X is 10, Y is 20. That matches. Sadie, does that match? That makes sense, doesn't it? I buy 10 apples. X is the number of apples. X is 10. Y is the cost. Y is 20. It costs me $20. One apple is $2. Every apple is $2 and so on. What if I do this? What happened there? Say that again? What do you mean by that? Huh? Yeah, I know you understand. You're not saying it the right way, but I know you understand what you're talking about. Very good. What would 5 apples cost, Corbin? $10. But this is saying the cost is 12. So, which would be 6 apples. So it doesn't match. 5 and 12 is a point on the grid, but it's not one that matches. Every apple costs $2. That's what points on the line means, is that the point matches the line. It's on the line. It matches whatever relationship that line is talking about. So y equals 2x is an easy relationship. And it makes sense in the real world. You can make sense of it. This one, not so much. 3x minus 5y equals 5. What is that? What does that have to do with apples? Well, maybe nothing. But again, so now we're not talking about a real world example. We're going to just practice some math. Okay? But it's the same idea. That's a line on the graph. Some points are on the line and some points are not. And we're going to check in 2 ways to see what that looks like. Does that make sense? Okay, so first of all, now we're going to do a little bit of math. This is the formal left side, right side check. We're going to do a bunch of these. We're going to practice them. And I want you to pay attention carefully because we're going to show it a very specific way. So I'm going to check this first point. What is the left side of the equation? You think of the equal sign as the middle. What's the left side of the equation? Kareem, do you know? What is to the left of the equal sign? Nice. 3x minus 5y. And so what is the right side? 5. What we're going to do is we're going to get both the left side and the right side down to a single number and see if they match. Folks, listen carefully. You have to set it up this way. Some of you are going to want to do it a different way. You can't. Okay, please try to do it this way where you have a left side separate from the right side. And once you're done with one side, you're done. You leave it. You don't have to keep writing it, so it's less work anyway. Now, what is x and what is y? No. How do you know what x is and how do you know what y is? Ryan? So what is x? X is 5. How'd you get that? Because we're checking this point where that says x is 5. And what's y? 2. Because this is x first, then y. So there, you've got your x, you've got your y. That's from the point. Okay, good. Now it's Ben Mass. What is 3 times 5? 15. What is 5 times 2? 10. What is 15 minus 10? 5. What happened? They match. So we make a little statement, left side equals right side. Therefore, the point is on the line. Now this line, the lines in your practice are nicer than this one. This one's a little bit messy. So I'm going to quickly rearrange it. It's I'm going to do it off to the side here. So 3x minus 5y equals 5. So one of the techniques we have to graph is y equals mx plus b. That's going to be the best one in this case. So I'm going to move the 3x to the other side. Negative 5y equals negative 3x plus 5. What do I do next? Nice. Divide by negative 5. Divide everything by negative 5. And I'm just going to do the math quickly because I want to get through this part. Negative 3 over negative 5 is positive 3 over 5. So there's my slope. And 5 divided by negative 5 is negative 1, so minus 1. So my slope is 3 over 5. This is review. We've done this. But it's good review of something that we need to know how to do. So my y-intercept is negative 1. And my slope is 3 over 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Everybody okay with that? There's my line. Good? Happy with that? I don't think you have to do any rearranging on the worksheet that you're going to do today, but that's how you would do it. It is something we've done. Now, what's my point? 5, 2. What did we find? Remember, algebraically, left side, right side check showed that the point was on the line. It matched. 10 apples cost $20. Match. Over 5, up 2. There's the point. On the line. See how it fits? See how the algebra matches the geometry, the graphing? And that's what all of this is about. Any questions? One more quick one. And then you're going to try. Check. 3, negative 2. So it's the same line. Left side is still 3x minus 5y. Right side is still 5. But I have a new x and a new y. Hannah, what's my x? 3. Evie, what's my y? Negative 2. Okay, watch my algebra. 3 times 3 is 9. Negative 5 times negative 2 is positive 10. 9 plus 10 is 19. What happened? Ethan, what happened? Left side is 19, right side is 5. What happened? Do they match? No. They don't match. Left side doesn't equal right side. They don't match. 5 apples cost $12. Wait a minute, that doesn't match. That's not $2 per apple. That's not the relationship we're talking about. Therefore, the point is not on the line. Let's take a look at this point. 3, negative 2. Over 3, down 2. It's not on the line. So going back to what I was talking about at the beginning, there's a couple things we were doing. Left side, right side check, done formally, showing our work properly. That's That's like kind of another major skill. We haven't really talked about it yet, but it's something that we do often in different situations. So we're seeing that for the first time in this course. But then we're also understanding that what does it mean for a left side, right side check to work in this case? If they match, the point's on the line. We saw it. If they don't match, the point's not on the line. We saw that too. Okay, I want you to try one. You don't have a grid, but you can just you can sketch it. So do the left side, right side check, and come up with a prediction of whether the point's going to be on the line. I'll help you get this one set up since it's the first one you're trying yourself. It's different, right? There's my equation. What's on the left side of the equation? Miguel, do you know? Very good. Lexi, what's on the right side of the equation? Awesome. Sub in y for y and x for x. Which one's y, which one's x? Okay, keep going. Okay, so you should get something like this. Left side was 1. Right side is 3 times 2 minus 1. 3 times x, but x is 2, so 3 times 2 minus 1. What's 3 times 2? 6. 6 minus 1 is 5. How many people got 1 on the left side and 5 on the right side? Okay, good. A few of you at least. Good. Very good. So what does that mean? Can somebody interpret that for me? Vanessa, what do you think that means? What? Yeah, you're on the right track. What's wrong, though, specifically? Ashley, what do you think? Okay, well, I'm going to start with that. Very good. Left side doesn't equal right side. That's like what Vanessa was saying. It's wrong. They didn't match. And what does that tell us? Point's not on the line. It's important that we know what it means, that we can do the math, but that we also know what it's telling us, what it means. Now, you can maybe just do a quick sketch of this, but you can watch first. Y equals mx plus b. Here's another quick review. Y equals 3x minus 1. So what is m and what is b? M is 3, b is negative 1. So b being negative 1, that's easy. I start here. When m is 3, what does that tell me? Up 3 and over 1. 3 over 1. Rise of 3, run of 1. So 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So there's my line. And remember when we first started graphing lines and I said something about how you don't want to just connect the dots. You want your line to go a little bit longer. So this is why. Because we're going to check if our point is on the line and our point might be somewhere else. So we don't want our line to be this small. We want it to kind of reach the whole graph so we can see. And where's my point? Over 2 up 1. Not over 1 up 2. Over 2 up 1. Not on the line. If you got your x and y backwards, you went over 1 up 2, you would have put it on the line. So when I'm working on this, when I'm practicing after we're done here, there's a check for every question that you get to do yourself. Does the graph match what you did in the work? Okay, try one more. Go ahead. Okay, right side was 12. That side's done. Some people get a bit confused and they think, what do I do with the right side? No, it's done. You're trying to find a number for both. So it's done. What did you get for the left side? I subbed in 6 and 4, and I got 12. So what does that mean? What does that tell us? They're balanced, they match. Left side equals right side, therefore, point is on the line. Now let's graph it and check. Again, you can just watch for a minute if you want. Yesterday, we used the intercepts method for graphing. So for a question like this, that's what I would recommend. And the worksheet that you have doesn't have enough space. So you could do the work on another sheet of paper, or if you think you can, just for this activity, I'm going to let you even skip those steps. Okay, so here's what I would do. If x is 0, I'm going to find the y-intercept first. So x is 0. What's 12 divided by -3? -4, so y is -4. If I'm going to find the x-intercept, y is 0. What's 12 divided by 4? 3. See how easy it is? Like, you don't even really need to show work. Like, I would even just kind of cover it with my thumb. Okay, so I want to find y. Y is -4. I want to find x. X is 3. Okay? And then I'm going to graph them. And I'm going to check my point, which is supposed to be on the line, 6, 4. So over 6, up 4. Look at that. There it is, on the line. How's that? Any questions?